Hello and welcome to my channel Crying Fly. My name is Steve and today I will show how you can creating a simulation over the cloud in Fusion 360 on Linux. Okay, we change to my desktop and then we starting. So, I opening my terminal, change to my folder Fusion 360 and here is it and running Fusion 360 now. Then I make here a little cut and then we go on with creating a study with Fusion 360. So here we are, and the next one what we're doing is I opening the project where I show you how can we creating a study with Fusion 360, and yes. So this is the project. I changed to the construction workspace. And yes, and here we can see now 4 profiles. Two angles and 1 blade. Okay. These 2 profiles here are fixed with the wall. And a weight rests on this blade, which presses the blade downwards. Okay. So we change back to the simulation workspace and I delete this one here. Okay. Then I make this one here. Okay. And yes, you can see now here this one and this one and this arrow here. When you start the first simulation here, then you can't see this one here. Okay. So then we see here on the top some options what we can do in here. We can creating a study. we can simplify this one here. I click on this. I'm clicking on this now. And here we have some options to modify, remove faces, fillets, and so on. You can deleting some objects what we doesn't need for the simulation, and yes. So we finish this. Then we have the next one, study materials, material properties, manage physical materials, and display study material colors. So when we click here on study materials, then we can see now here some values, the category, the name, the component, study materials, and the safety factor. And now we can see here an arrow because the original material of this plate is wood, and when I click on this one here, then we can see here I have selected the aluminium, and on every material where you can see here these arrows, this doesn't use for the simulation here. Okay, so then we can see here by the safety factory, the child strength or the ultimate tensile strength. And yes, and here we can select the object and can change this here. Okay, so then we can close this, and then we come to the next one, constraints. And here can you see these constraints, and then we have here the structural constraints that I use it for this two profiles here. Then we have the bolt connector and the rigid body connector. So then we have here the loads, structural loads. That can you see here. Come on, here. Then we have the linear global load, the angular global load, the option for toggle gravity on, edit gravity, point mass auto, point mass manual, and yes. So then we have here the contacts, automatic contacts, what I use it for this one here. Then we have the manual context and manage contacts. So then we have here the display for model view, toggle mesh visibility, top view, crops view, and yes. So then we have here the manage, settings, load case attributes, local mesh control, adaptive mesh refinement, and the solve pre-checked. There we can check if we have set the constraints and the loads and the contacts. And yes, then we can solve this. We can see the solve status, generate mesh, and solve details. So, and then we can export the study to ANSYS setup. We can look to the results, simulation results, inspect, and select here. Okay, but before we see this finished study here, we create a new one. We click on here, new simulation study, and now we can see this window here where we can select a study. We can select the static trace, we can select model frequencies, we can select electronics cooling. There is a good option when we maybe create a case for the Raspberry Pi with air cooling. Then we can select the thermal stress. This one is a combine of static stress and thermal. Structural buckling, nonlinear static stress, event simulation, and shape optimization. Okay, and here we have an option for help me choose a study type. When we click on this, then we can see now here the study type, and here we can select any study types, and here we have some information about this one, so we have easier to select one of these study types here. So we can select maybe on the electronics cooling. Then we see here it's changing the study type, or we clicking on the event simulation. And yes, I think it's a cool stuff for this one here, and it makes easier to select a study when I don't know what I select for my project. And yes, and when we have select one of these points here or here, then we can here click on create study that we make now with, I select the static trace, and then we create the study now. And now we can see here the study 3 static stress is successful created. And you can see here the study materials, the load case, contacts, mesh results. And yes, now we can see here this blade is not a metal one, but I go to the study material and change this study materials. No, that is not correct here. I change this to aluminium, so, and click on OK. Then we can see now this one is changed to the aluminium. So is our plate an aluminium plate. And yes, so the next one is we set up the constraints. We click on this one here, and now we can see here on the right side the structural constraints, the type, There we can select it here, fix it, pin, fractionalize, prescribe it, displacement and remote. We select fix it. Then we can here change the axis. And what we are now doing, we select the targets. So, and this, the targets now. So now we have selected all these targets, and we can see here the icons. And yes, so we click on OK, or we can here click on this little picture here. Then we can see here some informations and tips. More information, then opens the browser. And this is very good for us when we have some questions about this one. And yes, so I close this. And click on OK. And the next one is we will create a load of this plate here on the top. Okay, we click on this one, close this here, and now we can also select here a type: force, pressure, moment, bearing load, remote force, hydrostatic pressure, remote moment, and yes. So we select the targets. This is this one here. Now we can see here the arrows. And we can give this value. It's Newton. I give this 100 newtons. Then we have here the options to change the flip direction. Come on. Yes. Okay. We can change the direction type, normal, angle, and vectors. And yes. So I click on OK. And in the normal case is when we have here screws. Then we make here the bolt connector, but in this example here we don't need this one. So we click here on automatic contacts, generate, and so combine we these all objects to one, and now we can make a pre-check. And we can see now the study setup has all the information required, ready to solve. Okay. We click on solve, and now we have here the option to select where we will make this, and we can select on cloud. Or we can make this on our machine. So, but the problem is now then we get an arrow, and yes, so I show you what happens when I creating this on my machine here in Wine on Linux. I click on solve. Now we can see here the progress. Preparing model complete. Generation contacts complete. Now we can see here the error here by the solving. And when I click here on the ties, come on. Okay. And here we can see now this error here on the bottom side. And yes, I don't know, but I hope that I can solve this problem in the next time. And yes, so we close this and we change, so then we can delete this here. And go to the solve it study, what I have created with this option here on cloud. Here we can see this status ready, and yes, so I click on this one and click on simulation results. Not be computed yet. Would you like to compute it? No. Okay, I click on results. Come on. So, yes, warning. It's not interest. And now we can see here the finished results. We can see here the deformation of the blade and the profiles here. Come on. And now we can see here what happens. And yes, but this one here is the safety factor. What? Come on. Here, the actual minimum safety factor 6.99. The design appears to be over-engineered for the current analysis criteria. So, okay, then we can see this one here, safety factor targets, and here is a recommendation for this example here, and this one give us some tips what we can make. The first tip is use shaped optimizations to remove unnecessary material. Tip 2, try testing weaker, less expensive materials to reduce cost. And the tip 3, or switch to generate design workspace here to create lighter rake designs alternatives based on material, shape and performance. Okay, then we can click on this one here for more informations. And yes, so the deformation score, okay, adjust. But when we will see the actual deformations, then we click on this one here, and then we can see here, then we can see that our project doesn't have any deformations, and yes. So, and when we click on adjust 0.5, then we can see this here. Adjust it. Adjust 2 and adjust 5. Okay. And when we change this view here, then we can see what happens. And yes, so and then we have here the options to change this one here to stress, to displacement here, reaction force, the strain. Here you can see this. And the contact pressure. Okay. So, and when we will animation this one, then we have here on the top bar an option for this one. We can animate this one with this one here. And now we have here on the right side some options to play, stop, record, on way, two way. We can change the speed, the steps, and yes. So when I click on play, then we can see the transformation, and yes. So, and that was for today, and I hope you can learn something about this one here, and yes. So, I thank you for watching, and if you liked my video, then it's good when you give me a thumb up, please, and don't forget to subscribe to my channel Crying Fly. And don't forget to click on the little bell here, so you don't miss any news in the future. Okay, that was, and goodbye.